Hello, everyone, and welcome to this episode of the BimTube Podcast. Today, I've got Charles Kennelly from Esri UK. So welcome, Charles. Thank you for joining me.
Hello, how are you?
Good, very good. Thank you.
Yeah.
So as with quite a few of the guests, but particularly with us, we've been so busy that we've only just got around to doing this. So I do appreciate your time and your insights. So I've known you several years through, obviously I have a background in GIS, but for the benefit of people listening or watching, please could you introduce yourself? And I think one of the most important things, could you give us just an overview of how did you get into the current role that you're in? So some of your background would be great as well.
So I'm Charles Kennelly. I am the CTO of Esri Holdings Group in the UK. Esri Holdings Group is a company that owns Esri UK, Esri Ireland, and a company called Helix. And I'm the Chief Technology Officer. I have been in this role for about 12, 14 years, quite a while. I've been with Esri UK since 1997, so a long, long time. Joined as a programmer. I'm assuming people know who Esri are, but is that an assumption too far?
Why don't you explain? Esri. So this isn't focused necessarily on geospatial, this podcast. Yeah. So do explain Esri. It'll be great. Thanks.
Yeah. To explain that, I'll explain how I got into it. So I used to live in North Wales and dropped out of university. Found myself DJing for a living. That went for quite a while. It was good fun. But I felt a need to be in a normal world. So I started doing IT support. And accidentally found myself assigned to a project with a thing called GIS, Geographic Information Systems. And 2 weeks into that project, I realized that's what I wanted to do. I fell in love with the technology and what it could do. I was very surprised because I got to the age of 30-ish without ever coming across that technology, which surprised me because I had a technical background. And that's how I got into it. And it was driven by a passion for what it could actually achieve. So the thing that really tipped me into it was working in the highways department in North Wales and working with people who were designing roads, and they just built very bad roads, or they designed really bad roads. They were using the factors of cost and the factors of safety to build a road, but not the factors of impact on local community, impact on health, impact on natural environment, stopping the ability to mine minerals that were underneath the road. They didn't make decisions on those bases because they didn't have access to that information. And I had this sort of view that if you somehow could get all the relevant data together, present it to them in the right way, they'd make better decisions. And that's what the technology GIS does. And that's what I've been working towards, is systems that can help them build and design better systems for our planet. So that's how I got into it. Esri is a company who produces the technology that supports GIS. We've been going for about 50 years, absolutely focused on making the technology of geography available to people.
Great. Thanks, Charles. And like I say, even though in a few podcasts, obviously GIS and geospatial comes up, but that's not necessarily the focus. It's around the wider information management challenges. And of course, GIS is involved in part of it. But I mean, through your career, again, maybe for people that aren't familiar with GIS, are there any, just to start with, sort of typical applications? I know there's thousands or millions of applications, but just the typical use case in maybe the top three, just to get started, and then we'll move away from it.
Typical use cases, utilities is a major one. So gas, water, electricity, telco. So the management of their networks and the assets that make up their networks and working out how to optimize them and run them and so on. That's a major use case. The one that got me really, my first major project was forestry. I spent 11 years on that. And that's about mapping out where a forest is, mapping out what's in it, working out how you're going to manage it over the next 100 years, and then showing you the implications of that management so you can change it. And the management is for the production of timber, but also for the production of biodiversity and access and health benefits, and lots of competing sort of demands, especially in the context of the UK. We have a small island with a lot of people, a lot of competing demands, and no decision is made in isolation. So working on the forestry system really helped me understand the sort of interconnecting web of systems, and how one decision on one thing can impact everything else. Like somebody deciding to cut some trees down means that somebody's house is going to have lorries driving past it in the middle of the night and take that timber away, which means that their quality of life goes down and so on. So, everything's interconnected. And so back to your question, typical use cases, anything to do with where things are and how they connect with each other. Those are the use cases. Roads, crime, health, atmospheric modeling, flood prediction, and so on.
Thanks, Charles. There's so much we could talk about, but just this may be a loaded question, but do you think GIS is still a niche? Read into that question what you will.
I mentioned earlier what I was surprised that I had not heard of this technology, given how I think and that it's central to it. I mean, if you want to link different systems together, knowing where they are is a good way of linking them, and it can be a very formalized way of linking things. And I spent quite a lot of time just like wondering, why isn't this better known? Why is it a niche activity? And I haven't come to a complete conclusion of it, but my thoughts around this are there's a number of reasons. One is that the technology behind geospatial was or the techniques behind that were developed in the sort of late 60s, early 70s, and sort of moved into sort of production status through the 70s and 80s. And back then, the computers that we had available to us, they just couldn't do the maths. The maths required to run a payment system or a commerce system, or to manage your employees or your stock of materials that you have, is relatively simple, and computers can handle those sort of calculations very easily. The maths involved in telling about, does this polygonal area overlap this polygonal area, is just fundamentally harder. And the amount of memory required to store information about geography is higher. So I think at the time in which modern information technology techniques were being written down and codified, GIS, geography, spatial technology was just too hard to do. It couldn't fit in the mainstream because it was too demanding on the hardware. I got into this because of the excitement of what it could do, and found myself becoming a technologist because I had to be a technologist in order to achieve those benefits, because it was hard work. The memory required for drawing maps on screens, for interacting with them and so on, was just too high for the technology that we had available as to hardware and so on. Now we're in a position where the hardware is easy. There's plenty of processing power, plenty of memory, plenty of space. The maths can be done very easily, but the knowledge to make use of it has been lost and not built into the mainstream. So is it a niche? No. But is it in practice? It quite often ends up being. The other the thing that colors this as well, is because it's geography, there's a huge amount of associations with it. And the world of geography is huge. It goes from geology to human geography to everything else. Whereas GIS is actually quite a specific thing. It's about the relationships between information. It's an information management technique. I think it all gets mixed up with that wider geography, cartography, and all those things all get bunched up together. It attracts people who are excited by those things and misses the fact that there's underneath it a very fundamental information management technique.
Yeah, great. Thanks, Charles. Yeah, because of that specialized knowledge. I remember when I started my career with the UK central government, I was a cartographer, then a GIS professional. I even had my own room. But I'm sure them times are gone now. Interesting, isn't it? Apparently that used to be the norm. But yeah, I can for one, that was people didn't know what we did. But again, maybe shifting gear, because there's obviously we could dig into some technology aspect, and we will, because obviously that's your focus. But just to lead in with a completely different question, what sort of advice would you give to someone starting out in GIS now? So from a technology angle or wider, I know it's a very open-ended question, but where would you suggest people focus their efforts to make the biggest impact, perhaps on a technology basis?
Yeah, I think it's most of the people that we end up employing have got a geography background. They came from that sort of background, and sort of as part of their geography degrees or geography studies or interest, they stumbled across GIS, the tool for manipulating geographic information, and that became their passion or their career or their interest, because it's an interesting, exciting area. It's changing all the time. That's a traditional route into it. I came from more of an IT technology type background. I was big into databases and structures and information management and so on. And that's, to me, almost the more exciting way, because it unlocks a new way of working with information. So for people who are interested in information management and systems, there's a wealth of information out there. There's a wealth of systems to play with. I would just start playing with them. It's just, we've never had more access to technology. There's a lot of free technology out there you can use to play with it. So to just approach it not as geography, but approach it as information management, and a way of adding a dimension to the approach that you take.
Yeah, great. Thanks, Charles. One of the perhaps I can second guess what they might be, but this is about your opinion. What do you think some of the biggest challenges we've had as a GIS community with information management and data management over the years? Again, remember, people not from this background might not even be familiar with the terminologies we're talking about. So what are some of the biggest challenges for IM or information management for it?
Is it worth spending some time on some definitions?
Yes, absolutely. Whatever you think someone should learn that's not from, absolutely.
So we use the term Geographic Information System, GIS, and that is geographic information. If you think what that is, it's information about where things are. Either just a dot on a map telling you where something is, that's a piece of geographic information. A boundary telling you this is the district that here's a voting district, or the enumeration district for censuses, or this is the boundary of a city. That's geographic information. The assets in an electrical network, the wires and cables and ducts that they run through, all of those things have shape as part of their sort of essence. A cable runs along this road. It's this thick. It supports this much voltage. That's spatial information. How it relates to other spatial information is where the system part of GIS comes into it. This cable connects to that cable. They touch each other. They transmit electricity. This road meets this junction. And you can use the location of different types of assets or things to learn about how they relate to each other. So I went the road I was talking about earlier. You understand where a road is, its location, you can tell what land it runs over. And if you understand what land it runs over, you can look at the type of land that's there and say, well, this is ancient forest, and this is steep-sided hill, and this is open grassland, and this is a town. And you use the location to find other sets of information. Tell me where the forests are. Tell me where the people live. Tell me where the contaminated land is that I can't touch. You can use that location to reach out and grab other data sets to help you build your query and gain information about what you're doing. That's the fundamentals of geospatial technology, or GIS. Does that make sense to you? Do you agree with that definition?
I would, yeah. It's definitely about the questions. I think you've mentioned that at least twice or three times now, about asking questions I think one of the observations is, it isn't really a question, maybe you want to build on it, is that a lot of the time people don't know what questions to ask.
Yep.
Have you got any reflection on that, about how do we help end users get a handle on what could they ask? Because it's almost infinite.
It is almost infinite, and it's there's two parts to that. One is the visual presentation of things, showing people what's there. They can see what's there and start thinking, oh, that's of interest to me. That's of interest to me. That might make sense to this. So that ability to see things in context is really important, because you can make decisions about there's 150 different sets of information that intersect the place I'm working on. Which ones make sense to me? That's one part of it, and I think the visual presentation can help a human doing that. But more importantly, I think, is about you can send me. I can find out that, let's imagine I'm building a road and there's an electrical network that runs across it, and I need to be aware of it. You can send me all that electrical information. I don't know what to do with it. I'm not an electrical engineer, so I can't make sense of it. So I can get the data, but I can't get the sense of the data. And so it's more important to share the information about that. If you put a road over this, here's the impact of it on my system. So it's not so much about sharing the data itself. That's important. It's about finding ways of understanding the impact of what you're doing upon other systems, and the constraints of those other systems upon what you're trying to do. That conversation between those different systems is really important. And I see one of the major mediators in that conversation is the location of things, the geography of them. And it's about having experts provide information to me in a way that I can make sense. So they're telling me, they've made the decisions about what is relevant to what I'm doing, not me. I'm not competent enough to make that decision. So I think we need, when we are designing systems, especially for interconnecting different systems, it's about presenting the information that people need to make a better decision, not just a list of data.
That's a really, really good point. I think I've certainly seen it. Again, I would normally not say so much, but given I've already had a career in GIS, it's just to add, I think one of the challenges is, or has been, echoing your thoughts, is around that lack of metadata. I know we didn't say the actual buzz term directly, but anyway, that catalog, that description. Have you got any thoughts on how metadata has improved or not in our sector? I mean, sorry, we'll move on to broader technology questions in a minute, but really these are key things.
Yeah, metadata is absolutely vital. So once again, the term for everybody, metadata is data about data. It tells you about the data set you're trying to interact with. It tells you where its provenance, ideally its quality, and so on. And I've done presentations this in the past, talking about why metadata is always neglected, and how tedious it is to maintain and keep up to date, and how little it often gets used. And I think metadata is absolutely vital, and I think the approaches we have to creating and maintaining it are not good. It's like filling in a timesheet at work. You know you have to do it, but nobody wants to. And unless it's policed very carefully, they don't get filled in, or they don't get filled in time, consistently. So a lot of metadata that's out there, I don't think adds huge value because it's inconsistent or poorly maintained. To me, metadata should really be created by asking questions of the data itself. Very, very simple things. When were you created? That's usually date stamped somewhere. When were you last maintained? Very simple to get. How many features are there in your data set? That's easy. And so on. And you start asking better questions of the data, and a lot of metadata can self-sustain it. However, going back to the previous point, having good metadata still doesn't tell me what to do with it, because I need expertise to do it. So I'll keep going back to this road example because it really did inspire me. There was a part of one of the roads that I saw being designed went through an ancient forest, and it bisected the forest. And each fragment of that forest could not sustain red squirrels. They weren't big enough. However, if you connected the two fragments together, even with habitat that they wouldn't live in, but they could traverse through, you effectively still had a big enough habitat for them. The knowledge of that was locked up in a certain ecologist's brain and not available to the person doing the road. The metadata about that landscape could have been available ad infinitum, huge amounts, but the person building the road did not know what to do with it. What should have been shared was not a data set with metadata. What should have been shared is, if you cut this in half, you need to provide this access route. The wisdom about what to do about that is what needs to be shared. Otherwise, we're asking too much of the person asking the question, because we can't all be experts in everything.
Charles, you got my mind firing off now, because talking about forest corridors is something I've been involved with it. But you're right, because there's data management, information management. I guess we won't get to the semantics for the benefit of this podcast, but we're talking about knowledge management, aren't we? Now, traditionally, is that beyond the scope of GIS? Traditionally, are we? Wow, knowledge management. Where do we go from there? How do we retain that knowledge? How do we improve that? Not just the data.
So just your question there, is GIS even part of it? I just see GIS as fundamentally an enabling technology. It's a way of linking together multiple data sets in a relatively cheap way. Because the only thing I need to link two data sets together is a knowledge of where they are, where their components are. Nothing else. I don't need a common identifier. Well, I have a common identifier. It's their common geographies. And I don't need those things maintained. So that's, is GIS even part of this? It's just an enabling technology, but it's a very powerful one, and it's a poorly understood one, and therefore not leveraged. And I think the lack of that use means that people try to create common identifiers using traditional techniques, that are fragile and brittle, because things change in all of these systems, and the more systems talking to each other, the more things are changing. Therefore, you just can't keep up to date. It becomes too onerous. And I've forgotten your question.
It was about knowledge management. I was just throwing it in there more for the benefit of people listening or watching, because I know we could probably have a prolonged conversation about knowledge management. But how do we improve knowledge management with GIS? Basically, that's
So the GIS is an enabling technology that can support this stuff. But quite often, what is the knowledge? It's a process run against data. Yeah, if I look at, going back to forestry, I look at a piece of Sitka spruce in Scotland, and I think I'm going to cut it down in 5 years' time. I can probably work out how much timber is in there, given a few attributes. I know what to do with it. And I can publish an API where I've published that knowledge, not that data. So I can simply give you an API that says how much timber is going to be produced in this area in 5 years' time. And if the felling plan changes, then the API will give you a different answer. And that API is just a list of questions you can ask. And those questions behind the scenes are actually running processes. They might simply be accessing data, but they could be actually running analysis. And if you are analyzing data at large scale across multiple data sets, one of the tools that you should leverage in that is geospatial technology, because it can help you link together those data and run analysis you can't run in other ways.
Thanks, Charles. Again, just for people's awareness, maybe should we assume people know what web data and web services are? Have you got anything to add about the impact, good or bad, that web services and open standards have made? So again, maybe people won't be familiar with them, but
yeah. So a web service is that's the best way of defining it. The best way of defining it for me is to think about what we did before. Web services. When we were integrating different systems, we quite often integrated at the data level, as in we agreed common schemas of information, and I store my information this way, you store your information that way, and then we can talk to each other. The problem is that I'm storing my information for my business purposes, not for yours, and I tend to change it. And when I change it, things break. What a web service did is it introduced an agreed interface that we both use to talk to each other. So you have an interface, I have an interface, we talk to those interfaces. Behind the scenes, my database can be changing all the time. I can use different technology for it. I can swap one vendor's database for a different vendor's database. As long as I maintain the web interface, the web service, with the information I've agreed with you, then I can do my business and still share information with you. And we have a less fragile relationship. And I think that the introduction of simple web services, especially REST, and you can talk about whether you want to define REST as an approach, has absolutely revolutionized our industry. It's made the process of different systems talking together so much easier and enabled. I know it's led to an explosion in the use of GIS and mapping and cartography. Things like Google Maps, ArcGIS Online, our product, Carto, all these other systems just couldn't exist without web services. They're absolutely fundamental. And the reason is they remove the complexity between different systems talking to each other, or at least reduce it.
Thanks, Charles. I mean, you mentioned it. I'm going to have to go there now. What is the RESTful
I've almost forgotten. REST is a type of web service. Stands for relational state transfer, I think. I can't even remember it so long as it's a brilliant. It's a relatively simplistic approach to providing web services, and it's easy to work with on the internet. It works in a very internet friendly way. I'd suggest people just go and read up on it if they're interested.
Yeah, I think that. So thank you so much for that. And again, I'll provide links to things obviously we mentioned, because people can go and read more. But I think that change from, like you're saying, from a data-centric database level to now, I don't know, whatever people used to call loosely coupled or whatever web, that's absolutely massive, because it provides, like you've already articulated, that freedom to share data. Have you got any? I mean, maybe I should ask you more detailed questions. You're the CTO, so what are some of the emergent technologies that perhaps I might not be familiar with, or things that you can share? So maybe the top 2 or 3 trends that you think maybe people haven't heard of that are coming and making an impact? Or we might have heard of them, but what's
definitely
making
will
a
have
big
heard
impact?
of them. Some of the things that have really made an impact in recent years around imagery. Without wanting to go into more definitions, there's two broad types of spatial data we work with. One is lines on a map and dots and points and polygons and enclosed shapes, and the other is imagery, pictures, remote sense data, so satellite imagery or drone imagery and so on. And there's been a real, over the last 5 to 10 years, like just revolution in the ability to extract information from imagery. So usually driven by artificial intelligence types approaches, where we are able to recognize objects in images or categorize imagery very quickly and automatically. So for example, at Esri, we have a map of land use for the whole planet down to 10 square meters. It basically categorizes the whole planet into 10 land use categories. And I could have done that 30 years ago by sitting down with lots of maps and taking lots of time and categorizing land and looking at pictures and so on and creating a map, but it would have been a huge undertaking to do for a whole planet. We have an automated process where satellite imagery streams in at relatively low cost, gets analyzed by some tools, AI-driven tools, and a map comes out the other end. The whole process has been automated, and we can keep a map of land use for the whole planet up to date at relatively low cost, and have it refreshed, multiple times a year. That just wouldn't be feasible even 5 years ago. That sort of image analysis, image object detection, all those things have really transformed the use of remote sense data and are actively shifting the ground under our feet about how you survey the world and how you present information about it. And one thing that really sort of interests me is we've got huge amounts of raw survey information available to us. So remote sense data, people taking pictures of things, even smartphone pictures, orientated imagery, as we call it, where you're aware of what angle a picture was taken of and so on. Pour all that stuff together, put the rules in place, automate the whole thing, and mapping products can emerge just without any human intervention. Basically, raw survey data comes in, mapping information comes out. 3D, 2D, categorized, thematicized. We can just automate that whole production of maps completely using the tools that are available to us now, primarily driven by AI.
So, I mean, again, that's where like you say, that some elements of it may have been feasible at small scale years ago, but you're talking about like you've already said, the automation, the scale, the repeatability.
The scale at which we can work is incredible. The other thing I find exciting is I've seen very much in the history of Esri, each time we have made the technology more accessible. By accessible, I mean easier to use, quicker to run, cheaper. Our user base has grown, and quite big jumps in the amount of people who use the systems. The biggest recent change was in 2012. We introduced an online SaaS version of our software, relatively easy to use and so on. And our user numbers are in the millions now, and people accessing that system is billions. And we couldn't have done that without that ease of use thing. I think the AI tools that we see coming out right now, large language models and how they can interact with the technology, is another jump in the usability of systems. Because you can start doing some of the analysis that we talked about and the asking questions of what data is relevant to me using AI support to help us with that. So if you look at a modern geographic information system for a professional, it's got a screen with a map and a list of data sets and ways of connecting to them, and an infinite number of buttons and tools and tasks for doing the various things you want to do. We can replace that with a voice interface. We can come along and say, can you tell me the impact of this road on the local environment? And an answer will appear. Now, there's lots of questions about how valid that answer is, whether it's been hallucinated or whatever, but that's work that people are doing. So I see not just being able to operate at bigger scale being really important, that's vital, pardon me, but also opening up to more people because the accessibility is increased massively. That's really important.
Charles, that's brilliant, because I was going to touch on, I think you've articulated it perfectly, about the channel shift or whatever we want to call it, the change in technology and certainly the big one, like you've mentioned, just over a decade ago was ArcGIS Online, and I think it's absolutely massive, because occasionally I'll reconnect with people that haven't used GIS for a long time, and I try to. It's like, where do I begin? Because and the way in is often around dashboards and things like that. Have you got anything to say maybe about what Esri did, or maybe still calls geo enablement, so embedding geospatial capabilities into other tools? So it's maybe not even apparent that we're using GIS sometimes. I find that really fascinating as well. Have you got anything to say about that?
Yeah, right. I think, in most cases, you shouldn't need to know. It's just an information management technique. If I give you an example of a system that I've worked in the past for an insurance company, if you call up that insurance company, they will take your address. They will then geolocate that address. The person typing the address in doesn't know that's happening. It just, a system pinpoints that address. It then uses that at that precise point to go and ask questions like, what is the flood risk of this property? Traditionally, they would have done that by maybe a postcode area. But as you know, a postcode area can be quite large, and half a postcode could be at 30 meters above a river, and the other half of this postcode could be right at the level of the river. So postcodes are a very crude approximation of geography. We take a precise point, we work out exactly what height it's at, we work out what its flood risk is, what the crime risk is, what the exposure to pollution is, what the likelihoods of subsidence is. All those questions are asked using a GIS behind the scenes. And what comes out is a premium, a quote for a customer. It also does analysis like, although we understand the risk of that individual property, we've already insured 20 other properties around it. Our exposure is high as an insurance company. So it might be that they understand the risk of that thing, but they also need to balance their own risk as a company. All of that thinking and processing happens, sub-second. The operator of the system, they type in an address, they get a number. That's it. Behind the scenes, APIs are being called, data sets have been linked, GIS is being used. Nobody needs to know about it. There's no map on the screen. That's, to me, like almost the perfect GIS. It's helping people make better decisions, unless you're the person asking for insurance and the number's too high.
Yeah, it's a really good example where it's like in your example, you're absolutely, for the user is focused on the decision. It's just what is the best method and way of portraying the information. Have you just
reminding me something that quite not frustrates me, but people think that GIS is mapping and mapping is GIS. To me, a map is just a way of showing the information, showing the answer. It's a useful tool for demoing things and engaging people, but it's not about the map. It's about the relationships between data. It's relationships between systems. That's what it's about. We use a map as a way of showing the answer or of engaging people, but they're two separate things. The business of linking information and the business of showing things on a map are different.
Yeah, and different skills required.
Yes.
Yeah, I'll leave that there. Discuss, right? Not everyone's a natural cartographer, let's put it that way. But it's really interesting. I mean, I don't have an obsession with the dashboards, but there is something about that as an entry point. I mean, it's really curious to me that business intelligence or analytics and more of the more classic business intelligence tools, the functionality could and is replicated through some of the Esri solutions. Now, do you still think that there's an opportunity? I mean, I think there is. So I just wonder what you mean, what you will say to this about getting more into the pure business intelligence side of things. I mean, I think there's enough there already often.
Yeah, and that is definitely a trend that's happening. So in Esri, there's two technologies that really opened up mapping and GIS to the masses. One is dashboards. So presenting people a dashboard that has usually a map in it and related information. It brings it to life in a business intelligence type way. That's been really, really good, and it's still, growing. Its usage is growing. The other one was story maps, which we might come back to. But we're also do a huge amount of work to embed our technology in other business intelligence tools. Power BI being a perfect example, where that's a really, it's a quickly really growing area for us. So once again, other business intelligence tools harnessing or accessing geographic content, either for display purposes, to show the answer to things, or as a user interface component where tell me about this area, or as a back-end processing to get better answers. The problem that I've seen over the years is many business intelligence companies employ data scientists and so on. Data scientists quite often are not trained in the use of geospatial data to the level that they could be. They're aware of it, but it's not in their DNA. They have maps on their dashboards, but their maps are usually devices for showing answers. They're not driving queries. They're not linking data sets together. They link the data sets using traditional techniques, common identifiers, and so on. They're not making use of that geospatial bit, which is why I still think there's this demand for geospatial focused dashboards. But this is definitely a growth area of organizations reaching into our APIs to ask better questions to drive their business intelligence.
It's interesting you mentioned potentially some business intelligence or data analysts might be creating passive presentation maps. I think that's really interesting, isn't it? Because as we know, technically, given the right data, it's not that challenging to make them interactive now, the map we're talking about, but people don't think about it. They don't go there. They don't actually, understand the potential and the opportunity around it and how to go about doing it once they do. Yeah, and that's if there's one thing I'd like to change is have I think geospatial techniques should be a common information management approach taught to data scientists that's as fundamental as SQL, that's as fundamental as some of the AI tools they're going to use now. It's an absolute fundamental, but it is not approached in that way. We shouldn't. The industry I work in shouldn't be as niche as it is. I completely agree. We will mention story maps if you don't mind. I did actually have that on a list. I was going to mention it earlier, but so what are story maps and what impact have they been making?
Story maps is it's a way of fundamentally it's a website that there's an authoring tool for making a website, and that website can integrate mapping information, so people can see a map with layers of information and click on it and learn things about it. It can integrate video, it can integrate text. You can think of it being a bit like WordPress, but with mapping really front and center in it. And there are thousands of these things made every day to tell all sorts of stories, from people documenting. If you go on holiday and take pictures on your smartphone, you can come to a story map and say, take this folder of pictures, geolocate them on a map, and create me a travel log. And then you type in information about it and share it with your family. That sort of thing happens all day. Or people, talking about the top 10 volcanoes in the world and having a geographic tour around them. And the map is just a user interface control that takes you to different pieces of information. But they've absolutely exploded. And there are thousands of these things made every day. There are hundreds of thousands of them on the web. Just do a search for story maps and you'll find them. And they range from the delightfully amateurish to the hugely polished. We've seen local authorities use story maps to do their local plans and communicate their local plans and development plans with their community. We've seen board of directors using story maps to do their end of year reports and so on. So it really has democratized access to the creation of geographic central storytelling.
Great. Thanks, Charles. And obviously I'll link to some examples.
Yeah, it's great fun. I mean, it's well worth exploring these things and making them yourself. It's great.
And of course, by definition, they're interactive. I think that was the other thing. So where I nearly mentioned them before was when we were talking about knowledge management, because by definition, in some way, a story is being told. So again, that implies a broader, anyway, move off that topic.
Yeah, I mean, it's just touching on that as well. I mean, one of the best ways of engaging people, one of the best demos you can do if you're trying to sell mapping software is show somebody their house. Show me where I live. When Google Maps came out, the first thing we all did was we looked at our houses, then we looked at our neighbors' houses, and then maybe you looked at where you were going on holiday. We cared about things closer. So I once did a map of sentiment of tweets with their location about HS2, and you could basically see the HS2 line if you just did a heat map of how intensely people felt about HS2. The closer they were to the line, the more they cared about it. So you could actually derive the proposed line for HS2 from how people felt about it. using location. And it's one of the ways to engage people is we care about what happens to us and our families. And nothing makes information more relevant than if it affects you. I think that's part of the power of geography.
Sorry, Charles, talking over you. It's a really good example, that sentiment analysis. I remember the Esri talking about that with the Gulf of Mexico. It was a long time ago now, but I've seen it. This is sentiment analysis, so geocoding tweets in the example you gave, several times still in the water sector as well, trying to head off customer complaints about leaks. So, and again, it happened to be Esri products that were being used. So I think it is there and it is being used. We'll my time is brief with you, so I'm gonna have to mention them. Digital twins.
Yes.
So again, just very briefly, what are they, and what I guess critically, what has Esri been doing, and yourself been involved with digital twins, and how are they related to GIS, and what impact are they making?
Yeah, so there's many definitions of them, but a digital twin is a system which exhibits the same behavior as a real system. It mimics a real system. So it's a computer program that can give you the same answers that a real system would do if you were running it. It mimics the real system. So for example, if a real system is an electricity network, I could have a digital twin of that network. And I can say things like, if I have to service an extra 100,000 people, what will that do to my infrastructure? What extra capacity am I going to have to provide? You can ask that question to the digital twin instead of building it to see what happens. And so you can use digital twins to monitor an existing system. Like, imagine you've got a road network and you want to see where people are. You can look at the digital twin of the road network and have icons that show you the traffic levels. You can use it to manage it, turn on those, change the speed limit on that road. You can use it to optimize it. What happens if the population falls in this area and there's less demand? What will that do to my system? What happens if the population rises? What happens if there's increased flood risk because of climate change? How do I manage that? So a digital twin allows you to monitor, manage, and predict the behavior of real systems. And they're absolutely vital to helping us, as we have more demands on the systems we run and climate change and so on, we need to be able to predict what's going to happen and to help us make better decisions. Coming back to what we talked about. The overlap with what I do in GIS, a map is a digital twin. A digital map is a digital twin. It represents the real world. You can look at a map and you can understand things about the environment you're looking at. Every single GIS that I've worked on, I would categorize as a digital twin. Not every digital twin is a GIS, but every GIS is a form of digital twin. So I've been working on digital twins for 30-something years. I just didn't call them that. I call them geography, mapping, GIS. A new way of describing what I do, a newer way, is these are digital twins. They represent real-world systems, and they help you understand and manage and optimize them. That's the link between the world I come from and the digital twin world. I find it really interesting because one of the biggest benefits you can get from digital twins is when you link them together. So the electricity network needs to understand the water network because it might get its power from a hydroelectric station, or they might want to build a pipe over the top of a water pipe and the two clash with each other and so on. Or the water system needs to understand how electricity is available to run a pumping station. They have to talk to each other. And if you want two systems to talk to each other, you need a common identifier to link them together. And that comes, for me, back to geography. That's one of the best common identifiers we can get between different systems. And that's why I'm particularly interested in the national conversation around digital twins, and especially interconnected digital twins. Great.
Thanks, Charles. Obviously, that term will be new for some and not for others, but I think, a reflection on what you've said, I would certainly agree that many elements of GIS reflect what's now being talked about with digital twin, and it is that systems. When you say systems, obviously we're talking about the infrastructure system and system of systems. Again, this is people listening or watching, and that connectivity has always been thought about, but I think that the benefit now is about automation, isn't it? We can automate that and look at that connection. Have you got any examples? I know you've been involved in the Digital Twin Hub in the United Kingdom. Have you got any use cases or examples of sort of digital twin applications?
It's difficult to pick one out. The major ones that I work with are the utility type systems and the linking together. So if I can just sort of divert a little bit, I think geography has 3 roles to play in digital twins. The first one is most digital twins are of real world systems that have physicality. They are in a place and they have a shape. And if you're not using geography to model them, you do not have a good digital twin. So you could look at something like, for example, the digital twin of a capacitor, electrical capacitor. You can predict its behavior and everything else. There's nothing geographical about it, but that capacitor could be installed in a car and be part of its drive system, and that car has a location, and understanding that location and what it means and how much charge it can carry and everything else. The location is really important for linking that digital twin of a capacitor to other systems. So having a knowledge of the geometry, the location of something is really important to have better digital twins. So that's one role. The second thing is that all of these digital twins operate on our planet, in the world. So the geography of them all provides the context in which they all operate. The electrical system is inside the UK. The water system is in the UK. They're in the north of the UK. They overlap each other. They happen on a terrain which defines their characteristics in many ways. They are exposed to wind. They go over different soil types. They have to be aware of the bedrock in some cases and so on. The geography is the context within which every digital twin operates, and it can use to find out what's available to it from the natural world and the built environment. So that's the second role, is providing context to these digital twins. And the third role is interconnecting them. I once worked on a system where there was a database made to drive a dashboard for street lamps. It was very impressive. It gave really good information about street lamps for a large city in the UK. And it was all based around linked data. There's lots of clever technology going on to drive this dashboard. It was very good. However, it couldn't be kept up to date easily, because street lamps get moved, new ones get added, old ones get decommissioned, and so on. And very quickly, the data behind this dashboard became stale and expensive to maintain. It could be done as a one-shot, but it's hard to maintain. If it had have got the geographic location of those street lamps and the streets that they were on stored and used to integrate the data, then it would have been self-maintaining, because when the people who moved the street lamps around updated their system, the links would reconfigure because the geography was different, and you would have a self-sustaining system. The integration between different systems needs to understand and make use of geography as a common identifier. So those are the 3 roles. Better digital twins if they understand where they are and they use geography to model themselves. The context within which they all operate is within our world, which is a geographic system. And then when it comes to interconnectivity, geography provides a common identifier between a lot of systems. Not all, but a lot.
Yeah, great. Thanks, Charles. That example of the asset register with the street lamps is something these challenges still go on, as you well know.
And that's my frustration, is they still go on, and when they're, the information is available for how to handle these things. The knowledge exists. It just doesn't exist widely enough.
Yeah, and have you? Again, this might be a loaded question, but do you think, or what do we do about it? I guess so. I would assert there is still a challenge between different domains. So maybe we touched on this, but just explicitly. So, for example, you've given examples in utilities. I've got partly a railway background, but how do we get people in different domains, different sectors, different industries to share knowledge? Now, I still find it a challenge that some things are quite hard verticals in people's minds. What do we do? What's Esri doing, and what can we do as a community?
I think there's a number of things that help with that. One is examples, and more widely understood examples of where it has succeeded. I'll come back to something on the example thing in a second. I think another one is better teaching of the skills. So I think we need to have degree courses that give more prominence to geospatial techniques and equip people with what they need at a fundamental level, so that the generation of data scientists that we're producing know how to make use of this in a better way. And I think more accessibility, making it easier to engage with. It can be very hard to engage with geographic-centered tools. Now it's got way easier, and a lot of our work at Esri is to make it easier again. I think there's a potential step change happening right now around using AI to help with that interface onto these tools. So I do think we're moving in the right direction. I just think it's slower than I would like, but it does feel like it's picking up pace at the moment. There is a broader understanding. I can now explain my job to my family in less than an essay, because they themselves have some understanding of this stuff because they've been exposed to things. So I do think it's changing. I just wish it had changed, and I wish it was a bit faster. And we just got to keep pushing at it.
Yeah, great. Thank you. I'd just encourage people to go to events that aren't their sector.
Yeah, no, it is good to get. That's one thing I enjoy about what I do, is because we work at this fundamental level, enabling information management to happen, you get exposed to all these different sectors like forestry and crime and utilities and so on, because you learn from every single one of them, and it is fascinating. So yes, working outside of your typical domain is vital, and a lot of what we need to do in the UK is we need to work on interconnecting digital twins. By its nature, that means different systems from different backgrounds talking to each other. And if we, I'm a huge believer in sharing data and data being open and available to people. But just doing that is not enough. It has to be the sharing of the knowledge and the wisdom about what to do with those things. I think we have the tools for doing it. I think APIs are very powerful ways of presenting a list of questions that somebody can ask of you. So I think we have the tools in place. It's just a matter of making better use of those tools and getting away from the stultifying detail that we have around, common. I'm not going to go into it right now, but no, I think we go down a path with interconnectivity where we build the world's most perfect systems. This is the precise definition of how you should store your information. And if you do this, then other people can talk to your system and it's perfect. Humans aren't perfect, and we can't run perfect systems. We've got to accept the degree of imperfection in these things and have good enough systems that can answer questions that are good enough.
Great. And of course, it's the people. Well, it may be some decisions may be automated as we go forward, but there's at least at this moment in time, there's a person involved in making that decision. So again, It's not only the technical skills, but the domain skills. My time with you, unbelievably, is almost up. That's gone very quick, but so thank you so much.
Thank you.
Yeah, it's gone so fast. But one of the things I normally ask my guests, and I'm sure there's hundreds of references, but maybe what's the top few online resources or references you recommend people to look up?
I don't have a handy list. I'm sorry.
No.
Just go and do some exploring.
Do some exploring. That's fine. So obviously I'll link to the obvious things like the Esri website and all the rest of it. But and OGC. But it was great to have your insights and the fact that you gave examples of utilities, for example. Again, it's not about the technology as a tool. I think, sorry, just to close on that part, you've said many times you use the word tool with regard to the technology, and that's how I've always seen technology. A lot of people don't. They kind of get too into the technology.
Exactly. It's transitory. I mentioned the forestry system that I worked on before. That was quite a long time ago. The system we defined was a way of structuring information and analyzing it. It has been rewritten in 4 different technologies now, as time moves on. Every time it's been rewritten as new technologies, there's people who didn't want it to happen because they were invested in that specific technology. Technology is just a tool. It changes. That's part of the fun of it. What's important is what it helps you do. And if there's a better way of doing it, let's go for it.
Perfect. Charles, that's a perfect place to end. I completely agree with your sentiment. So thank you so much, Charles Kennelly from Esri UK Holdings. And that was a great interview. And thanks for your time. Much appreciated. Thank you.